in this episode how to solve linear inequalities in one variable. Coming up, back into action. Hey guys, we will be solving linear inequalities in one variable. Well, the process, it's very similar to solve the linear equation in one variable. The only difference is, instead of this equality sign, you would either have less than or equal, like here, or it could be greater than or equal, like there, or it could be just less, strictly less, so there is no this little equality sign over there, or it could be just greater than, so strictly greater. So to sum up, there are 4 different variations. But to be honest with you, the steps are pretty the same. So the way you would solve them, as you would do a normal basic linear equation in one variable. So you are looking for actually x. So you want to get x alone on the left side and move all other terms constant to the right side. So you want to express, you want to make x kind of as a subject of the formula, if it comes to this. So for the first one, since you have this 4 added to this left side, you want to move this 4 to the right side. So the way you would do, just by subtracting 4 from both sides. So you have to do it to both sides. You have to keep it balanced. So you don't want to change the overall value of your inequality. So the same basically rules as for normal equations, linear equations, or general equations. So 4 goes away, and you would end up with just 2x on the left side. And since 10 minus 4 gives you 6, you would be left with just 6 on the right side. Now, you want to get x alone, x isolated. So anything that attach your x, in this case it's 2, this constant, you divide out. You divide out from both sides. So this 2 goes away, disappeared, and you would be left just x less than or equal to 3. Since 6 over 2 gives you just 3. This is your answer. I would like to give you a glimpse into this thing. So compared to linear equations, where you have only one, for linear equations, only one unique value for x, for inequalities you would come up with infinitely many x's. So it's not only one x, it's all x's that satisfy this inequality. So you could come up with x that actually less than or equal to 3, which are namely 2, 1, -1, 0, -10, -15, blah blah blah, list goes on, including these 3, because we have this equality included. So it's a set, in other words. It's a set of all numbers that make this true. Now, this is your answer, and technically we are done. But sometimes you are asked to represent your solution set on a number line. So all you need to do is just literally draw a number line, a straight line with an arrow, sometimes 2 arrows on the both sides, and you're going to place this number somewhere. Just place it, 3. Now, you need to represent this 3 by using shaded circle or closed circle. Why closed? You could basically pick between open and closed. So because your number 3 is included in solution, because we have this equality sign, you have to choose, you have to pick the shaded, the closed one. If instead we had just x strictly less than 3, you would go for open one. This is the difference, and you have to pay attention to this. This is important as well. Now, since we have x then less or equal than 3, we need to decide which direction we are going. Are we going to the right or we are going to the left direction? Yes, we are going to the left direction because it's less. So your solution, your x's, they are less than 3. So this way, okay? And I'm going to just shade it. And this kind of shaded arrow that goes toward left, heads toward left, indicates, it represents that solution set. So this is your solution set for this inequality. Now, moving on. This is very, very similar. And typically what you do, you want again get x alone, isolate x from other terms. So you have another sign, it's not less, it's greater than or equal. Anyway, you just keep it for now as is. And since you have this 9, the first step, it's basically multi-step process. You want to get rid of this 9 by subtracting. So you undo, you do the opposite operation, untangle this 9. You undo, so you subtract 9 from both sides, and you would end up, it goes away, disappeared. So in the next line, minus 4x greater than or equal, you keep it as is for now, since 17 minus 9 gives you 8. Now, similarly to what we did before, you want to isolate your x. And anything what attach x, divide it out, get rid of this. So in this case, it's not 4, it's negative 4, divide out. So divide by negative 4. And it comes out to be in the next line, x. Now attention, caution, warning. Since you divide both sides of your inequality by a negative number, the sign in the middle has to be flipped. It has to be switched to the opposite one. So instead of greater than or equal to, I'm going to write less than or equal to. And since then 8 divided by negative 4 gives you negative 2, it turns out to be x less than or equal to negative 2. Again, attention. Every time, to summarize, to reiterate, every time when you divide or multiply your inequality, both sides of your inequality, by the negative number, the direction of the inequality has to be flipped, has to be switched. So, again, if you multiply or divide both sides of your inequality by only a negative number, guys, so the direction of your inequality that faces has to be changed to the opposite, has to be switched. Whereas if you add or subtract the both sides of your inequality by a positive number, nothing changes. It's unaltered. So you don't have to change like we did here. When we subtract 4 or we subtract 9, we still keep the same sign. So just keep in mind, because this is vitally important, it's imperative, because many people forget when they divide or multiply, and it comes out a lot. And if you don't do this, if you don't change it, you would come up with the completely different answer, which is basically wrong. So just as a side note, it's like exclamation mark, caution, be careful, watch it out, always watch it out. Now, again, if you are asked to represent your solution on the number line, go ahead and you literally draw a number line which represents all possible real numbers you could ever think of. And you're going to place your negative 2 somewhere. And you're going to choose again, you're going to pick this shaded closed circle, because your negative 2 is included. It's not excluded in your solution. And you're going to choose where you're going, to the right or to the left. You're going to the left because less. It's all these numbers, all the way, this way. So this is your solution set graphically. Alright, that was just for starter and moving on. Alright, compound inequality. Let's dive into this. It looks like this. So this is basically, it is an inequality, linear inequality, but it's kind of double, or it's called compound inequality. Because, why? Because it's actually consists two inequality, like 2 in 1, 2 in 1. You see, you have two inequality sign. How to attack, how to deal with this? Now, the gist is you want to split up, you want to break it down into two separate linear inequalities and solve them separately. Now, how I'm going to separate them? You just simply close this part and you look at this like 3x plus 2 less than or equal to 17. This is your first one. Alright? Now, you're going now to close this part. And I'm going to rewrite it just in the reverse order. 3x plus 2 greater than 5. We split them up into 2. Now it's not compound anymore. You have two separated linear inequalities in one variable. And the way you solve them as we did before. So typically we're aiming for x, subtract 2 from both sides for the first one. Let's start with this. So in the next line of my work you would have 3x. 17 minus 2 gives you 15. And finally the last step, you divide by 3 both sides. So goes away 3 and your x is less than or equal to 5. We're done with the first one. Now, don't forget we have the second one. So we solve them separately. Now the same step similarly, so you subtract 2 from both sides. Bring down, carry down this 3x, drop it down. You keep the same sign, you don't need to change it because we're subtracting, yeah? So it's unaltered. Since 5 minus 3 gives you just 3. And the final step that brings us to the next step. By dividing 3, we want to isolate our x, get it alone on the left side. So it turns out, it comes out to be x greater than 1. Now, what you want to do, you want to kind of join these two solutions into one. Because originally, in the beginning, we were given compound inequality, like 2 in 1, as I said. So I'm going to put them together, bring them together. So your solution set, your final answer would be like you put x in the middle, and your x is less than or equal to 5. You write it on the right side. So also your x is greater than 1. So you place your 1 over here. And after this joining, after this merging kinda of this axis, you would come up with this. So this is your solution for this compound inequality. To represent this graphically, you literally draw a number line that represents all your x values, all possible numbers, real numbers, to be precise, and you are going to place these two numbers. So typically you place them in an order, in an ascending order. So since 1 is less than 5, so 1 goes first, and 5 you place somewhere goes second. Now you are going to choose the open circle for 1, since 1 is excluded, it's not the solution of your inequality, so 1 is excluded, and you are going to choose the shaded or closed circle for 5, because 5 is the solution, so 5 is included in your solution set. Now all your x's are placed, they are lying between 1 and 5, so actually this interval between, so this shaded area is your solution set. It's all real numbers from 1, not including 1, all the way up to 5, including 5. Now sometimes you could see that your answer for inequality could be written in the interval notation, or sometimes you are asked to write, or maybe you used to write interval notation. So the same answer could be written in the way of, you use the parentheses, and all these x's from 1, comma, all the way to 5. And for 5 you are going to use the square brackets. That square brackets actually represents that 5 is in the solution. 5 is included, not excluded. So we usually draw a normal parenthesis to represent that number is excluded. It's not in the solution set. It does not belong to the solution set. And we normally draw the square brackets. That means, that implies that your answer belongs to the solution set. So it's in the solution set. So this is just alternate way of writing the solution set. So again, you don't have to write both of these ways. So you could pick either way, or maybe you used to write like this. So it's entirely up to you or up to your teacher. Again, so this is the answer. This interval is the answer for this compound inequality. I offer my special edition, my special hot meal, as always, scrumptious. Now, looks like a mess. Even fractions, these pesky fractions, pops up, brackets, numbers. Okay, clean it up, clear it up. So you always start by collecting your x terms and constants, numbers. So since you have constants on the left and on the right side at the same time, so move them on the right side. So let's start by doing this. So you just need to subtract 4 from both sides at this point. So you undo, you do the opposite. So this step brings us to the next step. So x over 2. And I'm going to bring this entire parenthesis to the left side to be able to collect your x's over here. So you have to switch the sign, so it becomes plus 2, x plus 3. So you keep the sign of your inequality as is. You don't want to change it. You still have negative 3 there, and you subtract this 4. Now, things getting better and better. Over there, I'm going to distribute this parenthesis first, and the way I would do, just you multiply 2 by both terms inside. So this 2 applies to both terms inside. So that means by distributive law, distributive property, 2 times x gives you 2x, and 2 times 3 gives you 6. And you need to combine these two numbers. So since minus 3 minus 4 gives you negative 7, you would be left with negative 7 on the right side. Now we have again number, and we want to move it there by subtracting this 6. Okay, let's do this. Subtract 6 from both sides. You would have, so bring it down, greater, minus 7 minus 6, so here goes away, disappeared, gives you negative 13. Now, you have these two x terms, so both of these terms contain this x, so you want to add them up, count them up. And you have actually this x over 2, this kind of pops out at you, and you probably feel uncomfortable. Yes, I feel your pain, guys. I feel this way as well. So, basically, what does it mean? You have you have literally 1 over 2 in front of your x. So this is the same thing as if I would write 1 over 2 in front of your x. It's precisely the same thing. Now, all we need to do is just clear off this fraction by multiplying by 2 both sides of your inequality. So you multiply by 2 both sides, and this term also has to be taken into consideration. It gets multiplied by 2. So this 2 and 2 go away, so that's why basically we multiplied by 2, and you would end up with just x over here. Don't forget to multiply these 2x by 2, so it becomes 4x greater than negative 26. These two terms need to be combined, need to come together. It becomes just 5x, and you still rewrite it as this. Now finally the last step. The last step, we're almost there. You want to isolate your epsilon, so anything attached, just divide out. So you divide by 5 both sides. And this step brings us to the last one. So you would end up with x greater than negative 26 over 5. So this is your solution set. This is your inequality for that problem, for that inequality. I hope it helps you and train your brain. Thank you for watching. I know everyone hates maths, but if you like my video, please hit like, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss my new videos.